Hello, hello, and good morning. So, up until this point, we've talked about equations of circles. We've talked about the angles within circles. We've talked about inscribed angles. We've talked about central angles. And now we're going to talk about the relationships between angles and chords and what they have to do with one another. So, as a refresher, I want to go back and review a couple of things that I think are going to be really important in making the connections between what we've previously done and now what we're doing. So, I want to start off, what is a radius? So, that's something that we should kind of already have a grasp of. But the radius connects the center of the circle to any point on the circumference. Okay, it connects the center of any circle, so the center to any point on the circumference. That is the radius. Okay, so what is a chord? A chord is not going to connect the center, but a chord is going to be any segment that connects 2 points on the circumference. So where the radius had to connect the center and any of the points on the circumference, this one does not. It just has to connect 2 points on the circumference without going through the center. Okay, so on this figure down here, I want to refresh some parts of it that we need to understand. Okay, so first off, we're going to talk about, let's just talk about the red here, being right here. So that is our central angle. Okay, that's our central angle. Now, the part, that's where it's going to connect 2 points of the circumference to the center. Okay, that's how we know that's the central angle. Erase that. So now let's talk about what is in blue. So the blue is now, that is called the inscribed angle. It's still inside the circle, but instead it does not stop at the center. It connects the vertices that are on the circumference. Okay, so that's an inscribed angle. And lastly, in the green, we call that an intercepted arc. Now that intercepted arc, notice how the vertices are B and C. So it is going to refer to the central angle in this case, or the inscribed angle. Okay. So those are just some parts that we need to remember about the circle, the inside angles, and that intercepted arc. So now let's go back for a second and talk about the measures of the central angle and the measures of the inscribed angles when you have the intercepted arc. Okay. So here we are given that the arc BC. So this arc here is 67 degrees. And we're trying to figure out what the measure of BAC is. BAC. So that right there is our central angle. Well, if we have the intercepted arc, what is the central angle? What's the measure of the central angle? What's that relationship between them? Okay, and some of you might already be saying that they are congruent. So that means if that intercepted arc is 67 degrees, then the central angle is also going to be 67 degrees. Now, let's talk about what the difference between the central angle and the and the inscribed angle is. So back when we were doing this a while back, we remember that the inscribed angle is actually going to be half of the measure of the central angle. So inscribed angle is half of the central angle. That's what's supposed to go on that line, but I didn't put it there. Okay, so the inscribed angle is going to be half of the central angle. So, with that said, what would be the measure of that angle? So some of you might be saying it would be 33.5. So all of that is to bring us to this topic, which if you notice, there is a triangle here inside of the circle. When it is inside the circle, we call it inscribed. And a triangle is a type of a polygon. So an inscribed polygon, it doesn't necessarily have to be a triangle. But an inscribed polygon is going to be a polygon whose vertices, these are its vertices, are located on the circumference of the circle. So here we have that the measure of arc BC, so this arc here, we know is 82 degrees. So based on our work from previous examples, what conclusion can we make about that arc, and the measure of angle D, which is its inscribed angle? So remember that it's going to be angle D is an inscribed angle, and it's going to be half of what the central angle is. And the central angle is the same. So it will be half of the measure of arc BC. Okay, so if that's 82 degrees, then angle D should be 41 degrees. Okay, so let's take that a little bit further. So here we have a circle, and we have what arc DE is. So DE is 110. Okay, so what does that mean the angle D is going to be? Sorry, angle C, which is its inscribed angle. So it should be half of that, right? So that would be 55 degrees. Well, now let's look at the other one that we have. We have that this is 70 degrees. So its inscribed angle, E, should be 35 degrees. Okay, so that's that relationship. Now, let's think about this just a little bit further. So using your knowledge of circles and their measures, what conclusion could you make about arc CE? So we're talking about CE, which is here. And now, what conclusion can we make about that if we already know that this arc is 110 and this arc is 70? So think about what the measures of a circle have to add up to be. And you might be saying that it has to add up to be 360 degrees. So if that's the case, then that last arc should be 180 degrees. Well, if that is the case, then what is the measure of CDE? So we're talking CDE. So we're talking about this angle right here. Well, that's its inscribed angle. So it has to be half of whatever its intercepted arc is. And we just figured out its intercepted arc is 180 degrees. So in this case, the measure of CDE should be 90 degrees because that is half. That's that inscribed angle, which is half of 180. So in this circle, we concluded that arc CE is 180 and its inscribed angle is CDE. What will the central angle of this arc and inscribed angle look like? So where is the central angle going to be to this intercepted arc? Some of you might be saying that it would be right here. Well, what's the measure of that angle? 180 degrees. And it's also the diameter. So that's the other important part of that, is that whenever your arc, intercepted arc, is 180 degrees, then it will always be, its central angle will always be the diameter. Okay? So let's move on. Now we have a couple of examples, and I want you to use these examples to find out any missing arc measures or missing angle measures. And again, like the others, I will come back with the answers, but I want you to try and figure out how you got to them. So for this, the measure of arc DC is going to equal 128 degrees. And on the second one, angle DCE is going to equal 50 degrees. Okay, so this sums this up, and we'll continue in the next video.